from HSRC. Ms. Maja.
Mr. Tony. I'm just going to turn on my camera for a little bit before I start.
And wow, thank you guys. Really, you really gave us experts for the weekend to learn a bit more. And yeah, otherwise I'm still looking forward to learn a little bit more. But thank you very much.
Thank you. We do have still do have a lot of another experts coming up again. So yeah, do stay connected for the whole time so you can learn more.
Thank you.
Thank you. Oh, the Mr. HTML coder. Are you coming all right?
I've only received the presentation just now.
All right. While Mr. T is still working again. Okay, let's take just one more person. And this person has been rather more active, not more active, but inquisitive about every presenter. I think even when other presenters are watching, they're actually preparing, readjusting their notes because of the questions. Grace Queen, or is it Queen Grace? What's your overall take on from not from yesterday? Let's just take it from today only. Grace. Oh, now that we want an overview, she's unable to mute. I know you're probably very questionable, but it's good that you are keeping our presenters on their toes, and you're making them to reach into deep lines that they've reviewed again.
I'm not sure if it's the right person, but okay.
This is Nkosi Kone. Are you the Nkosi Kone I know, or you're the attendee?
It's Nkosi Kone, you know, link. Everyone.
Very good. Okay, sorry for poking, because I've seen some Nkosi Kone, in the comment section. But good to see that you have not yet just logged in and left your laptop there. Okay. No, I'm saying it's good to see that you're with us the session. We did not do like everyone, like log in and leave the laptop there and go and play.
No, this was very informative. There's no stopping when it comes to learning. So I think all the presenters, their presentations or the topics that they have covered, they're very informative and eye-opener. So I think for all the hackers or all the innovators, when they go back to the solutions, they need to implement or consider the data science life cycle, as Eva mentioned, also consider the cyber security feature or security specific feature designing. So here it is an eye-opener. So for everyone, whether you're in so developing in general. So yeah, I think that all sessions are very informative. Thanks, Nick.
Okay. Thank you, Ms. Ngozi. Well, she hasn't spoken in a while, so I just decided to poke her for a moment. It's fun to actually have people, being interactive. Okay. Tobega, I see you have your hand up. I haven't opened for question, but I'll take you. Tobega?
Good day, everyone. Am I audible?
Yes, loud and clear.
Okay. I wanted to ask, based on the workroom section, what is that section based on? I just wanted to clarify that.
Okay, okay, okay. I was going to explain it to you, but I do feel like the relevant person to give you like the most adequate and clear answer. And I think Wonyama.
All right. So with regards to those, it's a pity that we didn't have much time, but we'll outline that process when we are done here. But we're supposed to have actual working sessions, and that's where Sonke comes in as well. But we'll explain that process once we are done with this session. Time has really not been kind to us, and it made things a little bit tricky, but we got you covered.
Thank you. I think she's a good answer. Thank you. For those who keep inquiring about Sonke, I will well go against the advices of the household. I'll share my email, and you just send me an email with the subject onboarding on Sonke, and then I'll add you on Sonke. Okay, let's just a few things. Miss Aja, while we are waiting for connectivity, I wouldn't want to cut your time. Can you just touch bases where you can without your presentation while it's coming through?
Of course, no problem. I am going to get started. I don't see that questions for you in the chat box for now. Just to quickly get and I always look at, because you guys are always so very techy with your hacking and the coding and all of that, and I'm not quite there, but I always feel data is what you need to drive the innovation that we're getting from these projects. Just for you to be able to solve a problem that has to be a problem, for you to know that problem exists, for the ability to exist, to have data that shows that. Otherwise, you're solving problems that we don't actually need solving in a way, right? I'll be speaking specifically on this. I'm going to start with my presentation on this end. I'll try and make it as clear as possible in the absence of the visuals themselves. But just getting started on the spectrum of data and what open data is. So within inflation, and it's not adjusted for inflation, because you can't just look at the raw numbers and be like, oh, it's been increasing, when you don't factor in what the other variables would be to indicate whether it's actually been way. Open data for trend analysis. You can use open data for spatial analysis on the next slide. For example, in the slide, we have a map in an area that shows where the schools in that area are. And the yellow is the number of students in that school or like in that area. So the larger the circle or the bubble in yellow, the higher the number. So if you're looking at maybe how schools should be resourced, this could be you'd be able to quickly see, okay, the school would probably need this much resources because they have this many learners in it. But yeah, spatial analysis is a very common way to use that to present, and just besides presenting, just be able to visualize the open data that you would have gotten. An important thing with data is storytelling as well. That's on the next slide, please. So data storytelling is, communicating information tailored to a specific audience. So not everything is going to be in a data visualized way. People that do data storytelling every day are, for example, journalists. The example in this slide is, I'm sure you've been on the road and have experienced, or you are a perpetrator who drives a VW who thinks that the indicator doesn't work. or you see a wreck somewhere and you might have experienced this enough to be like, you know what, I think the worst drivers in existence are VW drivers. But we actually need to know that that is true. And if you were telling the story of this is a problem, you can see in this article that the actually problematic drivers mostly in the road are drivers of Toyota Quantums, followed by the highest, the Avanza, the Nissan NP300 and stuff like that. But also, as you were telling the story, you also have to obviously just look at this note. Quantums are worse because they're in the road a lot more. They're driving up and down, transporting citizens on a regular basis, so they spend more time on the road. But so data storytelling, so you could use it in an article like this, but you'll also be using data storytelling on a regular, because if you're like innovating, you're presenting what a problem is and what the problem is that you're trying to solve, you're going to be able to take this data and visualize it and communicate it to your audience, whether it's an investor or judges in this datathon, in a way that is specific to them, that makes sense to them, it's tailored to their understanding, to drive your narrative through, just to make it clear what it is that you're trying to, what the data is showing us, to be able to tell that story, so that the innovation that you're coming up with is considered to be important or relevant. But this is the same on a day-to-day, whether you're still a student or you're at work. Your presentations are going to include some data. Your data might not necessarily be in numbers like this. It could be in, I don't know, staff attendance. If you work in HR, what trends and attendance and lateness and leave taking is. So data is something that you use on a regular basis. If you were a student and you're trying to argue for an increase of an allowance from your parents, there has to be data to be like, listen, the amount of money you're giving me is not cutting it right now, because these things cost these things because of inflation or stuff like that. So data storytelling is actually something that we do regularly, and it's a skill that you should try to fine tune in your presentations as you move forward. So another common way in which we use open data is through interactive apps. The next slide, please. So within these apps, you have all of this data that people can be able to interact with the information that they're looking for, so that your information is not always coming up in text format or in graph format. People can just search for what they're looking for. So like an example here, if you're trying to, it's almost elections time, it's not local government, but you're checking who's contesting in your ward, you can enter your address and you'll see it like in a widget format, in a way that's interactive visually, and sometimes even with audio. So the person that's viewing the data is a bit more interacts a bit more with your data. If I could put it like that. Okay, say similar with the drug prices. Yeah, it's interactive in the way that you could literally just change the kind of the name of the drug or whatever you're looking for and go to the next one. The app makes it easier to use and more interactive. You could also use open data for training models. On the next slide, and a very common example is how you can use, how language models are trained to do language translation. So people that are more into AI and machine learning, you feed all of that available data into your model to train it to do things such as translating. All right, so moving on from what we can use open data for, we'll go back to finding and accessing this data so that you are then able to use it. So number one thing, I already heard Nick or Tiani tell you to open this toolkit, but if you Google open data ZA, a lot of you have used this actually. Here, it's a toolkit in a Git book where you're able to access or try to find open data from different departments and different, institutions, organizations locally and internationally in a wide range of topics and sectors. So, like if you're looking for education-related data, if you're looking for survey data, if you're looking for land and spatial data, healthcare data, and things like that, this is a very, very good toolkit to start with if you're looking for like public, national level, district level, provincial level data. It's a very good start. And it's also, if you can't find the information here, or like maybe if the information that's here is not up to date, maybe the report is from last year and there's a more recent report, it's a very good starting point that then tells you, okay, if you need more, how else would you go to the internet to, where should you look to find something else that institution or that organization or department might publish but might not be in this toolkit. But this is a very good place to start. Not only trying to see where you could source your data, but there's also just some information on how you can play around with your data, how you can do spatial analysis and things like that. So this is a very important and very good toolkit to use in general. And then, so after you've tried to find the sources of your data, whether it's from the Department of Education or whatnot, how can you then access and use that open data? All right, on the next slide. So the first thing is PDFs. A lot of reports from departments specifically will come in PDF format, and those PDFs will have tables. So you could extract that data from PDFs. You could use a tool called Tabular, which extracts data from a PDF and puts it into a CSV or Microsoft Excel spreadsheet. So you don't have to copy and paste or manually have to create those tables yourselves. So you can extract information from PDFs if you're looking at numbers, but you can obviously also extract text data from those reports, because not everything is quantitative, some things could be qualitative. And another way you can access your data is through CSV files or Microsoft Excel. So in some of these data sources, that's the next slide, please. Some of these data sources will give you that information, not in PDF or text format, but already coming out in Excel or CSV format. So you can download that file, open it, and proceed from that point forward. You can also use and access your data using web tables. So you HTML website people, that's a common way to extract data from web sources. That's the next slide, please. Web sources and create your table, have it like in a HTML table is another word for it. So you could, especially if you're using multiple data sources from multiple things, so you could also have those different sources in your table and update them as you're moving along. If you're a person that prefers to work in HTML anyway and you're not using your Excel or CSV files, you can also use APIs where you get data from whatever software or website into whatever platform that you're using. So that's the next slide, please. You fetch that data using an API and play around with it in whatever tool you're using for data at that moment. So those are some of the ways in which you can access and open this data. So we've highlighted PDFs, CSV files or Microsoft Excel, web tables, and as well as using APIs. Now we're going to talk about responsible data use, because we're all responsible citizens, but like a key, there's a lot of responsible data usage things that we could talk about. I'm just going to highlight or hit a few, and the first thing that I'm just going to talk about is the data visualization guidelines. So when you have this data and you're presenting it, how should you visualize it? You want to visualize your data in a way that's as accurate as possible, right? We want the data to tell us something, to show us the realistic picture. like what the actual data is telling us. So for an example in here, like if you're creating a bar chart, your bar chart basics we were taught like in school way back when is your y-axis should always start at 0. It doesn't matter if the figures that you have are all in the upper tens or upper hundreds, upper thousands. It should always start at zeros. This shows you like a more accurate picture of what the data is actually saying. If you had, for example, started at 20% because you're like, oh, the minimum number is just over 20 anyway, it shows a very inaccurate picture of what the differences are between Q1, Q2, Q3, and Q4 in this particular chart. So your bar charts should always start at 0. The width of your bar graph should always be equal. The space between the variables in your x-axis should always be equal. So just try to avoid manipulating your visualizations in any way that would make the picture inaccurate. So next thing in terms of responsible data use is data protection and privacy. So if you're a developer, this might be more relevant to you, but like if you're using data in AI, what things do you need? This is a checklist, like an example checklist of things that you have to ask yourself to ensure that you're being responsible in how you're using this data, and you're also implementing things that would ensure data protection and data privacy. So at each stage, there's specific things that you have to ask yourself before you, like, as you got the data, before you process it, as you're processing it and after you processed it. Then you also want to also ensure that you meet things like transparency, accountability, fairness, mitigating biases, because the data that we get, if you clean it or manipulate it in a certain way, you might bring in certain biases to the data, or the data could come with specific biases already, and that should inform how you deal with those biases as you use the data. And obviously, security and privacy. Security is something that gets hammered on a lot with data, so I'm sure you know a fair amount about that. But this handbook is a decent one. Okay, I was going to check. So this presentation will be available on Sonke. So you could also just click on this link to actually get to the source of this handbook. It's a very important tool, and that you will have to use as you're progressing and using this data, just to make sure that you're hitting all of these things and ensuring responsible data use. We should also talk about transparency and trust. So when you're presenting that data, we need to be able to trust. You should be transparent in how you're using that data. You should be able to trust that the information you're giving us is true and accurate as much as it possibly can be. To the next slide, please. Right. So because the data that you're using to inform whatever intervention or to develop whatever tool or platform is going to be used by real people. So that's why transparency and trust is very important. In this example, this is a workout app that kind of like helps guide you through it. Like if you were working out and you've injured yourself, for example, and now you're in recovery, and you have this app that guides you, like, oh, what route should you take? For proper transparency and trust, like if the recommendation is, oh, use this route because it's 3.3 miles, this is the elevation, and this is the duration. Why is this the route that you've recommended? It's more it's transparent. It's telling you like, oh, there's minimal elevation, there's an even surface, there's a set slow pace. This is why this is good for you. So you're not just telling me this is good for you, this is what's best for you. There has to be transparency and trust. So just remember, you're responsible for whatever the intervention is going to be, or the product that comes out of the data that you have presented. So transparency and trust is very, very important. And so just almost wrapping up, I've mentioned some tools. Well, I've mentioned one specific tool that you could use in My laptop is almost dying. So some of the tools that you could use in using data. So I've already mentioned Tabula. Tabula extracts data from PDF, means for CSV and Microsoft Excel spreadsheets. You could use Open Refine. You can use that, for cleaning and transforming data. A lot of open data can be a bit messy, and you need to be able to clean it and transform it before you're able to analyze it. And transforming it, if you're into data science, machine learning, you would have a bit more information. Like if you're trying to transform a variable into a range instead of like that number that you have there, you can transform it into, do you want to work with averages? Do you want to work with categories and stuff like that? You can do that on Open Refine, Flourish and Data Wrapper, more like for visualizing your data. Flourish is really good, helping with your data storytelling. Kepler.gl is if you're working with geospatial data and you want to analyze it and visualize it there. That's a very important tool that you could use for that. And that is the end of my presentation. Do you have any questions? If I have time to take questions.
Okay. Hello. Thank you, Miss Maja. Thank you for that. I don't find words for this kind of thing, but awesome, breathtaking, and more insightful and knowledgeable about data. I didn't know that data could be this interesting. I thought it was just graphs and everything, but eye-opening. Thank you for that. Thank you for breaking it down more thoroughly.
Of course.
Okay, I can only borrow you, but not now. I'm not allowed to borrow you time for questions for now. But questions are open always in the chat box. I think at the last session, after the last speaker, we will actually open for all around questions. So, but do keep tabs on the chat side.
Are the participants able to contact us through Sonke at this point?
Yes. Everyone is. Those who are not yet onboarded on Sonke, my email is on the chat. Do email me. Just send me an email with the subject onboarding on Sonke. I'll add you on Sonke, and you'll find every presenter there.
Perfect. All right. Thanks, everyone. I hope you enjoyed the presentation.
Thank you very much. Okay. I guess we had enough. We got enough more about data. I just need to look at this in this way. So, for us to build stuff, we actually for this datathon. Well, it's self-explanatory. It's data and datathon. So, I don't think I need to break it down even further than that, or I'll just it'll actually require medical attention if I break it further. Okay, I'm going to bring up the upcoming speaker. Okay, the upcoming speaker is actually a principal in AI engineering at Standard Bank. He's going to be walking us through the data science overview. So I will be pleased to call on Mr. Mabu Manailing. Mr. Mabu? Mr. Mabu, sir.
Hi, Mabu here. Can you hear me?
Most definitely, sir.
Okay. Hi, I'm just going to introduce myself. So my name is Mabu Manaideng. I work in AI engineering, and I've been asked to just give some basics on what's happening in AI, and hopefully walk you through some tooling and some open source methods that we're using today. I understand that the audience is mostly developers, and I'm excited about that because I want to sort of try to entice you on the idea that AI is just a tool today, and then just because you're a software engineer doesn't mean you cannot be using AI in your applications, and you really don't need to be a machine learning engineer or any sophisticated kind of thing to be able to start utilizing AI successfully. So I hope you find this as insightful. I want it to be a bit more technical, so I'm going to skip most of the presentation that talks just English, because I think that's not going to be useful, especially because my intention is for you to gather some insights into how you can start employing some AI techniques in your development and your products. So I'm going to kill my video for now, and hopefully I'm able to share my screen. Then I can start with the presentation. Somebody just shout if you can see my screen.
Yes, sir.
Yes, sir. Awesome. So like I indicated, I'm going to talk about AI as a tool. And like I also indicated, I have quite a lot of slides, but I'm going to be skipping the English parts of the slides so that we can get to the juicy part. I like the previous speaker's conversation about data, but because I want to sort of bring it home, I'd like to just continue where she left and try to get a sense of how we see data in AI, right? So for us, mostly data is not like the trends, it's not the graphs, it's not that. It's mostly what is the data, what constitutes the data? Because you know, when you want to train a model, when you want to, you know, like build some kind of system, you really need to understand the structure of the data. But in the past, structured data used to be what's popular, right? And structured data, you can think of it as any tabular type of data set, right? A pandas data frame, an Excel sheet, a SQL database table, those things, we call them structured data. So we used to be able to do like trend analysis as indicated and machine learning and other things on structured data, and it became very popular. But over time, we realized that we can do machine learning on any kind of data, we can do AI on any kind of data. So what we usually refer to as structured data would be things like images and audio and blah, blah, blah. So actually data is just a modality when in artificial intelligence. It's not, it doesn't dictate anything. It's just a modality. I can switch between audio, video, I can switch between text to train a model. And it's very, very important to remember that, because you have the freedom to build any machine learning model regardless of what the data is. Most people say, yeah, no, I can build a logistic regression model with a pandas data frame, but I've never built a speech classification model. But you can, because you can, you know, so you should really think of data as just a modality. The way we like to think about data is in the following paradigm, and you can go anywhere, and actually like any kind of AI or any kind of sophisticated machine learning, whether it's reinforcement learning, generative AI or something, it will always fall in one of these categories. So what we can do with data typically is what we say is descriptive analytics. So this will be trend analysis mostly. So you are describing the data. So for example, for a given company, how many women are software engineers versus men, for example, or what is the age distribution? That is describing data. You can do diagnostic data, and diagnostic is usually very important. It's like so you can think of diagnostic data as, for example, what they do on the F1 sports. So the F1 sports, I don't know if most people are familiar with it, but it's one of the most high-tech sports in the world. So, you know, on the F1 sports, they have data points about what's happening with the engine, what is the driver doing, what's going on with the speed, with every single thing about the car. So they can do real-time diagnostic analysis of saying, do we need to change tires? Do we need to do this? So that would be a nice example of diagnostic analytics. Predictive is now when you want to say, I know this, and then I want to predict what's going to happen. And this is the most common use of data. I mean, I think maybe second only to descriptive, because you have to describe the data always before you can predict anything. But yeah, this is what you're familiar with, like predict the income of this person given the following properties or something like that. Prescriptive is a bit more sophisticated. And this is when we feed all the data into a model, and then we start asking, what can I do? What should I be doing given all of these things? So this one is like, you know, it's more like the model becomes the oracle. So it knows what it knows, and then it's going to tell you what needs to happen without you trying to say, this is the data points, I want you to do the following. So it's a bit complicated to explain, but you can think of it as like, so for example, if you use Google Maps and then you want to get from point A to B, Google tells you what road to take. So that's kind of prescriptive. So it's prescribing to you what to do using the knowledge that it has. You don't know anything about the traffic, Google does. So that's why it can recommend a route for you. So that's prescriptive analytics. It's very, very important to sort of understand these things, because once you know all these categories, it's very easy that when you're solving a problem, you know that the data you have requires prescriptive. You know the data you have requires predictive. And you can have a combination of them. Most people try to jump to predictive all the time, but we find value in industry, we find value across all the stack. So, okay, I'm gonna skip through this. It's really just English, but I think AI basically, okay, maybe I should do this. So AI was born from from this pioneering book, back in, there's a couple of them. So Alan Turing wrote a book in 1952 wrote a paper to a conference, to a journal publication on computing machinery and intelligence, and introduced something called the imitation game, making the argument that you can build artificially intelligent systems that are machines that mimic the brain. But the fundamental theory behind artificial intelligence is this organization of behavior book. And interestingly, it was actually interpreted as an economics book when it came out, and then neuroscience and blah, 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 but then it came into computer science. And this Donald Hebb guy introduced this idea of Hebbian learning. So in neural networks these days, we like to talk about this thing called neurons that fire together, that are wired together will fire together. And that he basically introduced the mathematical principles behind that idea. And people started modeling this. Turing was one of the first, and then there was a guy called Rosenblatt. But what they were trying to do now is that taking the learnings from Hebbian learning, they wanted to mathematically model that organization of behavior. And then we have an example of this in biology, which is our neurons in the brain. So how can we bring that into mathematical systems? And you can see, for example, this is a single layer perceptron, and it's very intuitive. It's very, very simple. It's just a segment function. It's like the idea that you have like these numbers, and then when you push them through this mathematical function, they must give you a y value, which is the prediction of that function. And you can see it's really a simple sum. It's just a sum of the weights and the data points. And this became the first neural network, actually, that was built by Rosenblatt as well. But it had its own weaknesses. I mean, today, because of the popularity of ChatGPT, you've heard a lot about things like hallucinations, it's lying, it's doing what. But the fundamental problems are mathematical. There's something called catastrophic forgetting, where when you retrain the model, it forgets what it knew before. There is, all of these things create the complexities of a simple function like this. What weaknesses can emerge out of it? And we see, for example, even things like adversarial examples. So there is a field of AI called adversarial machine learning, where you can fool a model into producing the output you want. So you can think of a facial recognition system. You could give it an adversarial example that it recognizes you as Tiani instead of you being Mabu. So those are all the things that are mathematical limitations of neural networks and the current AI systems that we have today. And today, really, we're really just working with what we call artificial neural intelligence. So we are beginning to see what we call multimodal models, but they're still neural nets that are stacked on top of each other that are specializing on one task. What we are working on is what we call AGI. AGI is basically artificial general intelligence, which will mean that you have a neural network that can do anything that a human being can do. So if you said learn soccer, it will learn soccer without needing to be retrained. If you said learn how to drive a car, it will learn how to drive a car. Because today, if you took the model that's running ChatGPT and then you put it in a self-driving car, it won't know what to do, because it's a narrow intelligence. It only knows how to follow instructions in a text and chat type of setting. And a self-driving car also cannot play soccer. So it's like we need a neural network that can do all of these things. So that's what AGI is. ASI is what we call the singularity, is artificial superintelligence. So it will be a neural network that can do everything and more that humans can do. So it will surpass human intelligence. We don't know when we're going to get there. People are predicting 2045 and blah, blah, blah. But the current modalities that we are dealing with in AI, it's really not promising that we can get to ASI with this kind of architectures. And there is a huge confusion in the AI field where people ask these questions: what is AI? What is machine learning? What is deep learning? But all of them are really just one thing morphed into different states. So artificial intelligence is really just the general field of studying the the use of mathematics to make intelligence machine, the general. And then machine learning is an approach you can take, right? Is an approach you can take where you use statistical approximation to be able to arrive at a prediction. And deep learning is another approach that is still machine learning, but it's a very specialized version of machine learning that focuses on stacking a bunch of neural networks together. So the reason we say it's deep is because it is a bunch of layers, right? And that's really the distinction. And in machine learning, there is a lot of fields and areas in machine learning that people are working on, right? So in general, you can say we have 4 types of machine learning, or maybe 5 if you like to add adversarial networks, but they're still generative, so we don't wanna take them out of that category. So, but we basically have unsupervised learning, supervised learning, reinforcement learning, and generative machine learning. And unsupervised is when you don't have labels. So it's like when you don't know. So for example, typically in machine learning, we would say that you have a picture of a dog and a cat, and then you label it a dog and a cat. We call those things labels. In unsupervised settings, you just have a cat and a dog, but you don't have labels. So you can think of it as a kid seeing a cat for the first time. They have no way of describing what that thing is. They have no label. So in those instances, we have techniques that we use to be able to do machine learning and then be able to make accurate predictions without having the labels. In supervised learning settings, we have labels, so we tell the algorithm consistently that this is a cat, this is a cat, this is a dog. If it gets the dog wrong, we tell no, this is wrong, this is a cat, until it knows that this is a dog, this is a cat. Reinforcement learning is usually where it's common in embodied systems, where it's like you take feedback and then you put it back into the model so that it can know. It's usually have like a reward policy where, and this is typically how we learn as humans. So for example, every kid doesn't know that a kettle with hot water is hot until they touch it. Even when you tell them, they will hear you, but until they touch it, that's the only time they know that this thing is hot. And that's because of the reinforcement learning, the feedback that went back into the brain to say, when you do this, this is what's going to happen. So this is usually used in robotics, self-driving cars, and all of those things. And generative AI is the new sort of modality that became famous, but it's actually quite old because it started with like generative adversarial networks, where we were training two neural networks that get into this adversarial competition of trying to fool each other into what data points look like. But now they've been expanded to text and then images and video, and it's just amazing. But yeah, and then obviously they introduced this new concept of multimodalities, where now you can have one model that can deal with audio, with video, with text. And that's the next frontier. I think 2024 is going to be the year of multimodal models. You'll see OpenAI, Google, and all of these people introducing new models that can video, because that's the next frontier. Okay, I'm going to skip this. But yeah, so this is why we say these things are deep neural networks. You can see that you have multiple layers, you have input layer, output layer, hidden layers here. And where does deep learning work? So what happens is this. We've been doing machine learning for a long time. We just haven't been doing deep learning. And also, because of the explosion of the internet, we realized suddenly that we have terabytes and hexabytes of data everywhere. And then we're like, oh, if we can just take all of this data and feed it into a model, what will be the behavior of that model? What interesting things can it learn? What we found is that with deep learning, the more you make the model big and feed it with data, the more the performance increases. But with traditional machine learning, you plateau. There is a point in time where, regardless of how much data you give it, the improve anymore. But deep learning accuracy will improve as long as you add a new layer and add a new data point. And this is surprising. And this is what we call the scaling laws. But this is the reason why deep learning works, is because you can give it more data and it gets better. And then the reason, one of the things that I would like people to start thinking about, especially in 2024, is that AI and software have sort of morphed into each other. So the distinction I make is that there is AI research, people who are sitting in labs doing fundamental research, writing papers and producing frameworks and publishing them to us. But then for us models who are just trying to build products, we are just basically software engineers. And then what we do is that we just look at AI as a pip install. Like, you know how you will npm install your packages in JavaScript? So you just npm install AI. And then once you have that, you can do anything you want without necessarily also knowing what the Google researchers know about the model. You don't need to know that. You just need to know how it works. So the reason this happens is that what happens is this. when you work in an AI project, especially in production settings, like working for a big bank or a big organization, like the ML code that you write, the machine learning code that you say my model is making predictions here, it's less than 1% of the whole ecosystem of what the system is going to do. You can think about it. Like, for example, you first need to read data from somewhere. That storage is not a machine learning code. You have to deploy that as an API or some kind of service. That's software. It's not machine learning code. So what we find is that the machine learning is complicated because the machine learning code is just 1% of what the ecosystem is required. So for that reason, that's why people working in AI today, they don't even have AI degrees, or they are not AI researchers or blah blah blah. And this is one of my call to action, that you need to really get close to AI, because just because you're a JavaScript front-end developer does not mean you cannot know AI enough for you to utilize it. Because it's complicated, this thing. Like when we do it in production, we need everybody. We don't need AI engineers only. And part of the reason is because when you do applied machine learning, applied AI, which means basically AI in production, like making predictions so that customers can see them somewhere, or clients, or whatever it is, or your users. So what happens is that it starts with what we call AI infrastructure. So AI infrastructure is basically what computer you're running. I'm sure you guys know that you can run on CPU, on GPU, on tensor processing units, FPGAs. We have all kinds of compute. But AI infrastructure is basically the underlying piece of technology that all of your AI algorithms are going to run on. But then we have business analysis. So you cannot just start building a model. That will never work. What you need to do is always start with a business problem. What am I trying to solve? And I think this workshop is also intended to try to get you to think a lot about this. What am I trying to solve? Then you have, once you figure out what am I trying to solve, you need to know what data do I need to solve this problem? What model do I need to build? How do I deploy this? Because a model that's not deployed is not a model. Okay, so a model needs to be deployed. If you haven't deployed a model, it's not a model, because it's not doing anything. So it's just there, sitting there, it's just a toy. So you need to be able to get to the deployment. So the reason these complexities arise is because in every one of this life cycle, there is certain skills that are required. So a person who can deploy a model does not necessarily understand business analysis. So that's why that we say that we're opening up the AI industry to everybody. I call it the democratizing technology, because we require so many people. And in all honesty, in like the next 10 years, if you don't know AI, you probably will be completely obsolete. I don't think there'll be a job that doesn't have a component of AI in it. So you need to get close to it as soon as possible, because it's the coming revolution. And for example, this is a typical compilation of an AI team, a successful one for that matter. What happens is that there is gurus, right? There is these things we call unicorns that can cut across data engineering up until AI infrastructure, right? We call them full stack AI engineers. So this is a person who is a software engineer, who's an AI engineer, who's everything. It's very rare to find them. I interview people a lot. I think in South Africa, there's probably like less than 10 people who can do this. And it's a very, very, like, to be full stack of AI life cycle. And it's not difficult, right? Because you can learn anything. I mean, if you're a software engineer, you can learn AI. If you're an AI engineer, you can learn software. If you are a business, you know AI and software, then you can learn business analysis. If you know those three, then you can learn AI infrastructure. I don't know why you should stop anywhere on the stack, because you can just learn them. But typically, you'll find that somebody that we call a data scientist are usually involved understanding business requirements, data, because you have to understand the data that you're going to model with, and then doing the modeling. So we'll say you are a data scientist. Machine learning engineer, somebody who understands the data, who understands the model, and then who understands how to deploy. Because engineer means taking things to production. Data analyst will typically understand business analysis and data engineering. Then we have this new one, which is something that I'm really excited about, and I'm seeing that software engineers in South Africa are not trying to grab this opportunity. But this software engineer, ML person, it's a software engineer who sits in a machine learning team. And then what ends up happening is that they understand enough about modeling that they can build, like, let's say, inference API. And then obviously, because they are software engineers, they know how to make an API and then how to deploy. So all of these skills are things that you can morph yourself into. I don't understand why somebody must choose any of them. You can just do all of them and become a full stack AI engineer, a unicorn, and then get a job wherever you want and ask for whatever money you want. So if you look at the way and this is what we want in industry. In industry, we don't want you to just come here with Coursera certificates and say you are a data scientist. We want actual aptitude. And don't get me wrong, I don't believe in PhDs and actually I've concluded that I don't think people need degrees anymore because the internet is the biggest college. Even if you learned it on YouTube, what you must have. So we don't care about learning regression or something. We want the aptitude. So if you look at this, and I will share this report if anybody is interested. But when we actually interview and try to select who's going to work on what, we look at this kind of areas for specific roles. So you'll see a data science, mathematics there. And do you need to go to university to know math? No, you don't. You can learn mathematics on the internet. So everything I'm saying here, I'm not saying that you need a PhD. I'm just saying that you need aptitude. And aptitude can come from anywhere. It doesn't have to come from a college. It can come from anywhere, right? You can sit here, read a book, and then understand linear algebra better than a person with a PhD from some university without you having gone there. So I feel like people get confused there. So when I have years of experience, especially in AI, because if you say that I experience in building OpenAI APIs, who has been building OpenAI APIs 2 years ago? No one. So all of us are starting from scratch. So that's why years of experience are completely useless. But this is an opportunity where people can sort of build their aptitude. Aptitude is depth. Understand exactly what's going on here, but you don't need to go to university for that. Machine learning engineer, you can see the math is there. Machine learning, algorithmic coding. I mean, you can learn algorithmic coding. I feel like you learn algorithmic coding on the internet better than you can in any college or university. You know, the software engineer, machine learning guy, is a software engineer with a twist, like I said. And this is a good golden opportunity. If you already are strong in software engineering, like you know Python enough to write a PyTest, you know unit tests, you know all of these things, just get into machine learning a bit, and then you will become the software engineer, machine learning person who is very, very in demand. Many organizations have models that cannot go to production because data scientists don't know how to productionalize models. So yeah, I hope this gives you a sense of what kind of skills and what's required in the industry for us to start doing proper AI. So going back, AI is a tool. Like I said, if you are NPM installer, if you're a PP installer, think about, and I'm going to demonstrate how easy it has become to just incorporate anything machine learning into a workflow that you're building. Okay, so you're a Python developer, right? So you know that you can use pip for anything in Python. So one of my favorite one is Hugging Face. So you see here, pip install Hugging Face. I mean, pip install transformers, and then magic starts happening in your code base. Magic. Can you imagine that you just had a Python application that you built in Django or Flask or something? Once you just start pip installing transformers, shocking things start to emerge, and I'll just demonstrate that quite quickly. So, for example, transformers is a Hugging Face is an ecosystem, right? So what you're looking at now here, it's all the libraries that Hugging Face is building. Pip install transformers, but they also have these things called diffusers. Diffusers are mostly for, and I'm just going to go into this ones quickly because I know we're short on time. So, image generation tools with Python. Diffusers, you import diffusion pipelines and video generation diffusion models, right? So you Runway ML, it's one of the companies leading with releasing open source models for image generation and video generation. So on Hugging Face, you have access to the model, and then you get this, right? And these are pipeline. And look at this. And then you can just say that pipeline, an image of a squirrel in a Picasso style. And voila, you have an image. You didn't pay anything, right? This is just Python code. Transformers are a lot more powerful. Let me show you these tasks. Yeah, okay. So let's look at tasks. So in transformers, there is this concept of tasks, which are meant to, when I find them, and you will also be shocked by the simplicity. Okay, let me do this. Of just importing transformers into your code pipeline. And already we saw you can just generate an image. Which are 2 lines of code, you have an image that is generated from text. So if you're building a mobile app, when your mobile app is making an API to the server, API call to the server, they say generate an image of an old lady doing this or blah, 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 whatever. I mean, image generation has all kinds of use cases. Or you're an artist who's doing, you know. But look at what you can do with just transformers. You can do computer vision, like depth estimation. I don't know if you know depth estimation, but it's estimating the depth of an image. You can do image classification. You can do image to image. So you take an image, you put another image, and you generate a new image out of that. You can mask. So you can do anything basically that we call a computer vision problem. One of my favorite is this one, which is called zero-shot classification. So the idea of zero-shot classification is that you don't train a model, you don't do anything. You give a model an image and you give it labels, and then you say predict which labels are relevant to this given image. So for example, in this instance, we just take a cat, an image of a cat, and we give it classes. We say a dog or a bed. You can change this image to a car and then change the classes. So there's no fine-tuning, there's no modeling, there's no nothing. It's just it just works out of the box. That's why we call it zero-shot. And look at how easy it is. So you basically just say, okay, I want the following model that I want to use from Hugging Face. You start a pipeline, and then this pipeline, we're going to call it the zero-shot image classification pipeline with this model. And then I have the following image, and then I have the following labels. And then I want the model to make the classification. Once the model predicts, it's going to predict that, this is an image with a cat and a dog in it. And then it's going to say the label is a cat and a dog, and then it's this. You can use this for anything, not images alone. You can use it for anything. Or also, if you can imagine, I know that in banking, we have this fraud detection exercises that we do where we verify that somebody's bank statement is legit or is not legit. So you can take that as an image and then say, can you make the follow? Or even not that. Maybe you want an attachment that a client is sending you, an attachment that a client is sending, and then you want to classify it, whether it's a bank statement or it's an ID or it's a what. You don't need to train a model. You can just take that image and say, is it a bank statement? Is it an ID, a registration document? And then it will predict accurately which one it is. And you see how many lines of code? Like just about 3 lines of code with that. So there's no excuse why you're not doing AI if you're using Python. Natural language processing, we can do anything we want, summarizing, table question answering. They're here. This is just by saying pip install transformers in your workflow. Audio, and like I said, data is just a modality. We don't care. Audio, video, bring it, So here, for example, this one I like, audio classification. Audio is one of the richest data set that has not yet been tapped into. So most models are still not audio models. And audio is very important. I mean, you can think of working for an organization. People are always calling, call center. About 90% of call center operations is about people talking to. So if you can build an audio model, you can deploy it in very many different modalities and settings. And multimodal, like I said, now we can combine images and that are super fancy. But that's just by saying pip install transformers. One of my favorite is this one. Okay, yes. So one of my favorites is this one called supervision. Supervision is also an open source library in Python that is meant for image and video analytics. So look at this. With just this, you can take a video. A video like this one. Let me do this quickly. You can take a video like this one, and in real time, annotate these people. Right? You can predict where people are. You can do all of these things. Open source with less than 5 lines of code. You see this? This is less than 5 lines of code. People are doing cool stuff. Like for example, people are tracking players during a soccer match. You can imagine like tracking traffic. I mean, I know that we have cameras all over, our provinces, traffic cams and stuff like that. Models like this can be deployed very cheaply and very accurately. That's thinking about AI as a tool when you're building your products. Okay? Cool. Let's look at the idea of models as APIs. So part of the reason why models never go to production is because, like I said, data scientists don't like production grade. But it has never been easier to just take a model and make it an API, right? We have the things, for example, my favorite is Fast API. The other one that's commonly used is Flask. But look at how easy it is. So for example, you just have an endpoint called predict. And then you have your inference script. Your inference will load the model and then make the prediction. So you can think of in the inference script, you have Hugging Face, and then it's expecting some text and it's going to return a prediction. This is less than 10 lines of code. And then you have an API that can make inference or using a model. So like I said, there is no excuse for not doing these things in 2024. One of my favorite tools as well well is what we call Pandas that allows you to talk to data. So the idea is that you load data into a Pandas data frame. So you can see here, for example, they are loading countries, and then they are loading their GDP, and then they are loading their happiness index. Then once you have the data frame, you can ask a question. You can say, chat, right? I hope you can see this. Which are the 5 happiest countries? And because we can integrate Pandas with OpenAI, it's gonna call the GPT model from OpenAI and then answer the question. So we see that Canada is the happiest one, because Canada has 5 point something or whatever. I don't know I don't see where Canada is, but that's that. You can talk to data. So you can imagine if you have data, some data set, you can build a nice web interface where people can ask questions and all these kind of things, and then you render them in real time. It can do charts as well, so it can draw a graph for you. So you could say, plot the histogram of countries showing each blah blah blah. So this could be you read from a SQL database in a production setting, and then you expose that as a kind of data frame, and then you can ask these questions. So no excuse not to integrate AI. And today we live in an era of LLMs, right? I mean, everybody talks about LLMs today, and it's so simple. It's absolutely simple to integrate LLM into your application. We know that we can go directly to OpenAI. We have cross-border challenges here, but I would recommend people to look at Azure OpenAI services, because they can allow you to manage your cross-border data transfer issues instead of going directly to OpenAI. But you see, with like 1, 2, 3 lines of code, you can call an AI assistant. Well, in this case, you have to pay for them, because obviously OpenAI is not free. We have other things called Llama Index. Llama Index, I like it because it's very flexible in terms of like answering questions for own data. So you can see here, you just load some documents from a directory and put them into an index. Then you create a query engine, and then you ask, what did the author do growing up? Maybe you took a book. Easy, less than 5 lines of code. This one is another one that I like. It's chain. It's very quick. So embed chain here, you just give it an API key, and then you can see you can add an entire website. So you can add a website to embed. Embed chain will internalize the building of this is what we call retrieval augmented generation, by the way. So it's going to internalize and abstract away the building of the index in the background. And then you can ask a question. You add a website, Wikipedia, you do this, and then you ask away, This is how simple things have become. Another thing that I'm excited about, and I think 2024 is going to be a big year for, and I think this is useful for you guys as well, because I mean, the cost of these APIs that we pay Microsoft and OpenAI can get out of control very quickly. So one of the emerging trend is what we call offline models. So offline models is that companies are releasing open source models. So once the model is open source, instead of you just take that model and then use it in your application for free, because it's open source. Most of them are or Apache 2.0 for anything, utilize it and make money, and they don't care, right? One of my favorite one is Mistral. So you can do this in embed chain, where you tell it that use the Mistral model instead of using the OpenAI model, and then it's going to download the Mistral model from Hugging Face. All models from Hugging Face are free. They're all open source. And then now you can, this Mistral configuration will tell what embed chain must do. Then you can add the thing, and then you ask away. So similar to how you were asking, but OpenAI was answering, in this case, an open source Mistral model is the one that's doing the answering, and you pay nothing. Cool. The last thing that I want to cover is, and this is important, especially if you're in hackathons or this kind of boot camps and that kind of thing, is that what you need to keep in mind is that when you're integrating AI and doing what, at the end of the day, that what you're building must be demo ready. So most people will build mobile apps, that's great. You'll call an API, which you build in Fast API with few lines of code, as I demonstrated. Other people may build web applications. So there is a lot of tools in Python where you can build web-ready HTML code, right? So for example, Gradio is one of them. Gradio will create a very nice interface for you like a web app by writing this line of code. Streamlit is my favorite. So for example, look at what this Streamlit code will generate as output. So you can see this is already a web application drawing some graphs, but you just wrote Python code. And this is deployable as a web server, and then you can render it and you can do all these things. And as a last thing, I wanted to show you just this as an example. So for example, if you, because AI is so flexible nowadays, and then deploying web apps that are machine learning powered or LLM powered and stuff, it's never been so simple. If you look at this code, This is the code took from embed chain that integrates embed chain with Streamlit to create a chatbot. Also uses an LLM that is free. So I'm not calling OpenAI, I'm calling Mistral, right? So if you look at this, there, I mean, Streamlit is very easy to use. So you can see this is about 71 lines of code, but if we put formatting in place, it's less than 50 lines of code, okay? And this less than 50 lines of code gives you something like this, right? This is a complete web application, right? This is a web application. You see it's running on my local host on this port. I can deploy it anyway, by the way. I can deploy it. They're completely deployable, and then they can be internet facing where everybody can access them, you know? So if you really have nice ideas and you have AI and you have all the tools are there for you to start deploying this in the cloud and making money, you know, you can charge people for your services and those kind of things. So like using AI has never been so simple, especially for anyone, whether you're a JavaScript developer or blah, blah, blah. Because anything, anyway, one thing I didn't show you is this. So most people say, yeah, but these things are in Python. These things are what? No, Transformers has a JSON, has a JavaScript API. So if you're a JavaScript developer, Node.js and whatever, you have no excuse not to use this. Even TensorFlow has a JavaScript API. So you can use what we call TensorFlow JS. So there really isn't any excuse to not incorporate this kind of capabilities in your development. Just by doing that, I can have a bot and I can start asking away. Right? And the good thing is that if you integrate what we call, let me just authenticate myself here. If you integrate what we call a retrieval augmented generation, all of these things, you can do them over your own document. So you can imagine that you have a, what is this? Let's say, I'll delete this key after this. Let's say you are in an organization. Let's say you are a legal firm, right? You have a lot of cases that you know, and their findings and what happened, and it was who versus who. You just put those cases into an index, and you just ask, you know, what was the OD? What was the output, the finding of the case Mamang versus Mamang? Why did the judge say that? Do you know what I mean? And then you reduce 10 days of doing legal research into 1 hour of querying a language model. So there is a lot of potential, you know. But this one is just a general model, so we're just gonna ask who is Elon Musk, right? And the model, which is Mistral, it's been trained with Wikipedia data and into Common Crawl and all of these things. It will know exactly who Elon Musk is. But you see that with just these few lines of code, you have a web application of a chatbot that can literally answer through questions. And if you get sophisticated and do something like this, where now you want to say, I'm going to add my own, okay, something went wrong there, but you want to say, I'm going to add my own documents to this, and then you upload your PDFs or you consume data from somewhere, your website, whatever. But building this kind of capabilities has never been this simple. Okay, so I think that was my last thingy. And yeah, I think that's the end of my presentation, and I'm happy to take questions if there's time.
Okay. Sorry for that. Sorry for the echoing.
Nick,
let's allow a few questions.
Okay. Okay. Let's do that in an orderly fashion. Wow, I've already seen hands already. Okay. Mr. Mabu, you'll be able to answer.
Yeah, no, I'm happy to answer.
Okay. It's Francis. Francis, I'm giving you the podium.
Thank you very much, Nick. Mr. Mabu, can you hear me?
Yes.
Okay, so I've a couple of questions for you. The first question is, what do you think, what advice do you have for like cleaning data? Let's say one, like, what tricks or what insights can you give in like, if like maybe you want to collect a bunch of data and then you want to clean the data for training maybe models, different models, what do you recommend we should? That's the first question. The second question is, you're making it seem as if it's now absolute. It's actually now useless to actually like go in depth into AI, like really understand like the mathematics behind like the neural networks and whatnot. It's just you now like it seems to me like your best option as a person who wants to like get into AI is actually like use like already pre-trained models, and that's the best way you can actually like maybe excel in the field, instead of like going to the nitty-gritties, the mathematics, and like, you don't have to you don't have to know any of those stuff anymore. All you have to do is go straight into using or pre-trained models and stuff.
Okay.
And the last question, oh sorry, okay, and the last question is I actually forgot the last question, but can you please answer those two once I remember? I'll tell you.
Let me start with the first one. It's a very important question, and it's kind of controversial in my own mind, né? Because here is the thing: if you're a software developer, you're not you're not a machine learning researcher, okay? You are not. So I don't understand why you want to study gradient descent. You're a software developer. You build mobile apps, okay? So you don't need to understand gradient descent for you to put image generation into your mobile app. Let's just say that you're an iOS engineer, okay? Why would you want to know gradient descent when you're an iOS engineer? The argument is that just because you don't know gradient descent doesn't mean that in your iOS engineering, you cannot use AI. So I hope that clarifies it. There are people like me who have to know the mathematics of gradient descent, right? Because I will need to build a model from scratch given certain instances and blah, blah, blah. But that's a complete, so you need to know what are you doing, you know? If you want to be an AI researcher, you have to know the mathematics of AI. But if you're just an iOS engineer and you want to use AI, no, you don't need gradient descent in your life. That's my argument. And also, I think the idea there is to democratize these AI capabilities so that they're no longer in the hands of people who have PhDs, you know? Like your mobile app will not have Face ID because you don't come from Google. That's the argument I'm making. But there are still people who need to understand the linear algebra of gradient descent. And on data cleaning, okay, so data cleaning is the most messy process of any machine learning process. And the painful thing about it is that there is no shortcut, right? What I know though is that, for example, if you're building web scrapers or if you're building all these kind of things, there is a lot of open source tools out there that, like, you know, that will sort of almost solve that problems for you. Like, for example, if you want a web scrape, you can use Beautiful Soup in Python, and Beautiful Soup will almost always scrape any website and bring you the clean data. But yeah, part of my job, like, you know, it's like really cleaning data. It's like I spend a lot working with JSON files, trying to get data in a structured way so that it can be meaningful for machine learning. Cleaning like images, filtering data out. Like I work on a speech processing project recently, and I had to find like audios files that had like length of this and length of that and noise of this and noise of that in decibels. So it's a lot, but the point is that you cannot get away. There's no shortcut. So let me stop there so we can make room for any other.
Yeah, thank you very much.
Okay, hope you are answered, Francis. That's great. I am still not seeing hands on my end. Or maybe Mr. Mawu stood everyone. Now everyone is left speechless.
No, there are hands.
There are hands, mate.
They always used to prove me wrong. I see Sophia. Yeah, so Sophia.
Thanks, Yanni. Hi, Mavu. Great presentation, by the way. I just wanted to ask, so I'm not coming from a technical background, but more from a risk assurance within the IT space. And I wanted to know, with regards to data, right, and you guys feeding like information, what kind of, from a risk perspective, you know, they always say that which controls the data controls the narrative. So what are you guys doing to make sure that maybe you're redressing maybe how certain things were sort of projected for different groups? How are you making sure that the data is actually creating new scenarios that are actually representing all groups? Are you just taking any form of data and, you know?
Yeah, okay. So data bias is the biggest problem in AI today. I mean, one of the reasons why Elon Musk created Grok, he was saying that these models like OpenAI's ChatGPT are too liberal. So for example, if you ask ChatGPT, what does it think about the sovereignty of Palestinian people? as opposed to ask it, what does it think about the sovereignty of Israeli people? And it becomes absolutely controversial. If you say, what do you like about Biden? What do you like about Donald Trump? You know what I mean? So data bias gets incorporated into the models, ultimately. There is a lot of work that needs to go into data engineering when you're building any model. So for example, I'll come to generative AI like LLMs and other things, but even like in banking, for example, we are regulated, right? The SAP, South African Reserve Bank, regulates all banks in the country. So we have these things called model validations. Every team will have a model validation team. If you are going to deploy a model, let's say that makes credit decisions against people, that it didn't take you being a woman or me being black into account for it to give me little credit increase versus the white John. So in practice, we do a lot to ensure that data biases do not leak into models. We do a lot to work on what we call model interpretability, and regulated fields have to report to the SAP and whatever their regulators are in terms of what the models are doing in production. As a responsible machine learning practitioner, I always ensure that I make sure that certain features that we call them that could introduce bias in models are not even included in the training set, right? So for example, if you want to give me credit, why do you want to know that I'm a man? Or why do you want to know that I'm black? I don't know. Models should not know that. They should just say, based on the spend and the financial history of this person, and my bureau data, maybe let's say I missed payments, I didn't miss payments, can I give this person credit? So we focus a lot on that. On LLMs, and this is why, so LLMs right now can do two types of inference. So the two types of inference modes that LLMs can do is inferring from their weights, from their model weights. So after you train a model, you serialize it into something called a weight. So the weights, when you ask, you query the weights to say, answer the question. The reason why, if you ask GPT and you don't have browsing enabled on ChatGPT, if you ask ChatGPT, what is the weather like in Johannesburg today? It will say, I'm a language model, my knowledge cutoff is 2021, blah, blah, blah. That is because it's answering from its weights, okay? And that's where biases come from. So if you're just taking GPT's weights and answering questions in production settings, then whatever data with its biases that went into GPT, you are inheriting it. And this is a huge model risk. What I propose almost in all, okay, I worked on more than 15 generative AI use cases in my job. And in almost every one of them, what I recommend is what we call retrieval augmented generation. So the way that works is that you avoid the model from answering from its weights, but you give it the context in which it should answer from. So you can imagine that if you are searching what is the sovereignty of Palestinians, but you don't ask the model, you search documents, and then you take the documents, you send them to the model, and then you tell the model to answer from those documents. The model will answer from the verified articles from scholars or other people or that kind of thing. But that avoids the hallucination, that avoids the bias, that avoids its own internal mechanisms, because you are forcing it to answer from the documents that you generated. So if you ask Bing Chat, I don't know if you guys use it, but Bing Chat is actually the best way to use GPT-4 for free. If you ask Bing Chat, what happens is that Bing Chat will search the internet using the Bing Search API, and then give that data to GPT-4 to answer the question. So Bing Chat today, if you ask it, what is the weather like in Johannesburg? It's going to tell you. And the reason is because it's using a retrieval augmented system, not answering from the weights. So that distinction is what we bake in for bias safety when we think about building these models. It's basically our risk management strategy. I hope that helps.
Thanks, Mavu. Yeah, thanks, Mavu. Appreciate it.
Okay. It seems like you're on a rope. It seems like you're on a good rope. Tobeka?
Thank you, Nick. Am I audible?
Yeah.
Yes, you are.
Okay, cool. So I wanted to ask, for an individual that does not have a tech background at all, who's not used to software engineering and so forth. So how do I go about, because I just have my accounting degree background, that's it. So I wanted to know, in terms of embarking on this journey of AI, how would I be able to embark? Because there was a lot of information that was shared on the call. That's the first question. And then the second question I have is, how is AI impacting game-based learning currently? Yeah, those are the two questions that I have. Thanks.
Okay. I'm going to disappoint you, but okay, let me start with this. Okay, maybe let me start with the disappointment. So there's no way now that you can just use AI like without, like, I don't know, like, you're in accounting and then you want to build a model that will analyze your books and then maybe forecast that you are likely to spend this much the following income statement. At the end of the day, code must be written. So the argument is not that if you are an English teacher in high school, you can just pull something from a tree and then you have AI. The argument is that it's so simple to integrate AI when you build systems. So build systems is the keyword, right? So there is this guy called Andres Kapati. He said something very interesting. He said that in 2023, the most common programming language was English. And the reason he said that is that for the first time, all we do is we query models. We don't write most of the time. We don't write code. I mean, even when I'm writing code myself using Copilot, I just write English. I say write Python class that receives data and do what. But you see, I can do that because I know what a Python class is. I can do that because I know what code is. So there is still some minimum requirement, but I think that in the short to near term, actually in the near to long term, coding is going to become somewhat obsolete. It's going to become like AI research. So AI research now, it's like a very narrow field. We still need them, but it's very few people. And we're still going to need programmers, but they're going to be few of them. But they'll be the ones who build these natural language interfaces for us. But we're not there yet. But today, for example, if you're a brand manager or something, and then you wanted to generate an image of your brand for a campaign or what, you can very immediately just use text to do that. You don't have to write any code. You don't have to know Photoshop, and that kind of thing. So there is still some empowering that is emerging, but it depends on the field. But I don't think you can build an app with AI if you are from accounting and you don't know how to write a single line of code as yet. I mean, people who write code would know that no code or low code environments have been very disappointing. It was a very huge emerging trend, people saying there's gonna be no code, we're just gonna build apps without doing anything with drag and drop. Where is it? Show me one app that is on a mobile on an app store that was built with drag and drop. It's not there because you still have to write code, So yeah, in the future you won't have to, but for now there is still a lot of code in that record. Although be it if you're coming from accounting coming into AI, the entry is not as difficult as it used to be. Okay, so for example, I actually have this program where I take like people with no AI background because I want to prove the point that you don't need to go to a university to study data science, something like that, to be able to be a good data scientist or machine learning engineer. So I have this program where I take people like that from biology, from law, from blah blah blah, and I introduce them to AI. And I have one lady who is right now is a manager, a data science manager who studied soil science at school. So, but what that entails is that you will code in Python and learn how to use open source tools to integrate AI into your capabilities. But it doesn't mean you can't code at all. You still need to learn how to code.
All right, thank you so much, Mr. Mab.
Okay, thank you. I want to give you one. Just going to take who's first? Carl.
Yes, thank you. I just want, because I'm in the data science and AI space already. I just wanted to ask in regards to ethics and regulations in South Africa. What do you feel about like things like social manipulation through AI algorithms? Because we have a controversial case about China using TikTok to sort of derail the youth of America by displaying certain content to their audience. And then when we are in China, you have them displaying students loving mathematics and all of those things. So, interesting topic. Just like to get your view around it, because I think it's something that can potentially become very dangerous, especially for someone who understands the intricacies of what you can actually do with AI at a surface level and a high level.
Yeah, it's a bit of a political question, to be honest. But the what we know is that governments of the world are working actively to weaponize AI. So, and obviously South Africa, I mean, we don't feature anywhere when people talk about AI, right? It's like we're non-existent in a way. But yes, there is proof of governments of the world weaponizing AI. Because if you think about it, I mean, if South Korea used LLM to generate a malware that can attack infrastructure from a grid perspective or something, weaponization of AI. If we could use an LLM to like sort of monitor a hashtag, an election hashtag in South Africa, and then in real time generate tweets under some handle so that they can influence who gets voted for. That's manipulation. There is that social dilemma Netflix show that people can go look at just to understand the concept of weaponizing AI for these purposes. We have a lot of problems. So, for example, in computer vision, we know that there was a study that was conducted where the commercial facial recognition systems recognized white male faces with a 99% accuracy, but black female faces with a 67% accuracy. So, and these things will continue to emerge, and it's most like, you know, what we spoke about when we spoke about AI risk. It's really just something that needs to be managed. And right now, I'm sure you know, OpenAI's CEO, Sam Altman, has done a world tour talking to governments and asking them to regulate them and all of these things, especially when we start talking about things like like artificial general intelligence. So when the AI becomes general, then our problems will be even quadrupled, right? But my sense, especially in South Africa, is that we are featuring anywhere when it comes to AI regulation. I mean, I haven't read any white paper from any regulator in the country talking about AI, you know. So yeah, I think the country itself, it's far much behind, but we can find inspiration on countries that are looking forward. And there's many countries that are forward looking on this topic. But it's a big one. AI is the number one emerging risk. Was the number one emerging risk at Davos, at the World Economic Forum, and I think it's number one for the second year now, because as these models become complicated and sophisticated, they introduce a lot of risk. I mean, you can think about jobs, you can think about other things. I had an interesting conversation with an executive in the industry once, where we designed this architecture that could automate call center operations. So the idea, so if you think about why people call call centers, so they'll call call center to say, I want to check where my claim is, or I want to log a claim, or there was fraud on my card, or what. But you can have a model that just